So here's my link belt 135 spin ace. I really like these little excavators, except for when they do this. I bought this particular machine at an auction. As you can see, it's plumbed on the stick here for a hydraulic hammer. I think probably what happened is it had a pretty hard life with the jackhammer on the end before I got it, causing the metal fatigue here. You can see the metal's been, it's somewhat crystallized. It looks like it's been work hardened. It's cracked all the way through to the other side, getting ready to crack across the top. It's broken across the bottom. And we're going to try to weld this up and plate it. In the meantime, I'm searching for another stick off a used machine or a burnt machine. A lot of times you can find these excavators of all brands have caught fire, but you know, they're still parting them out. Again, you can see this side's pretty messed up too. Anyway, I'll document the removal of this thing and the repair. Show you how we're going to repair it. Feature my brother's welder that he invented. His stealth welder, as he calls it. And I think he's even got a patent on it now. But it's capable of running some pretty large rod, a very high tensile strength rod. But needless to say, this is pretty exacerbating when you're trying to get work done and something like this happens. I was just in loose sand, scooping sand at my home, which I've documented that project on a different video. And I just reached down for a bucket of sand and pulled it up, and as I pulled it up, the whole arm, or a whole stick here, just swung right at me towards the cab and wouldn't stop. So I had lost control because it snapped right here. I thought it was coming through the cab at me, but it did stop and threw a little dirt on me, but no harm was done in that respect. But it took me a minute to figure out why it did that. I thought the ram up here had failed. I didn't notice this crack because at the time when that happened, it was just a hairline. It just looked like a hairline crack. It wasn't very noticeable. All this damage has occurred just from moving the machine, walking it up to where I could haul it and getting it on the trailer. Believe it or not, just doing that is what really made it look so much worse. So anyway, it's a bit of a chore. Take this thing off. I think my brother's going to be here to help in an hour or so. In the meantime, I'm going to close this gap up and just lay in a little MIG weld, probably here on the other side as well, just to hold it in place. I think we can get this to close up pretty well using the hydraulics on the machine. And if we can just get it held into place, then my brother can take it to his shop and V it all out and lay in some nice welds with his welder and then plate it. Wish it was a Komatsu. It's my understanding Komatsu has a lifetime warranty on their boom and stick. So I've never seen any excavator do that. I have seen excavators break the very tip off of their stick, right where the pin goes, right behind this pin that holds the bucket on. This pin right here. I don't know if I got that in the first shot, but anyway, I have a twin to this machine just around the corner here in the yard, so I'm going to probably load that one up in the next day or two and take it back to the job. In the meantime, hopefully I can get this thing back up and running here in a few days. Let me do it again. Got a little hot bead of metal. See, it lays down a lot of metal. You might want to put a little water in there. So anyway, we're just spot welding this thing back together to take the stick off. I already put really careful not to touch the side of the spot in with a MIG welder, but the MIG's not working too good, so my brother Tyson is now using a stick welder to try to get a better spot weld on it, just to hold it together so when we take it off it stays in position. So here it is on the trailer. Unfortunately, I had nobody here to film while we took it off using the other excavator. Wasn't too bad, just held it up with a strap as we drove the pins out, and then slung this thing and picked it up and slid it forward on the trailer and set her down. We had the trailer under it as we disconnected it from that machine. Biggest problem is the oil was going everywhere. Now we can get a better look at this. It's cracked all the way around. That's the top there. Luckily I had another machine here in the yard to help us with this, getting this disconnected and laid down on the trailer, because it's definitely a heavy piece. So far, none of my connections have been able to find a replacement stick off a machine that's being parted out, or sometimes they take them off to put longer sticks on. Haven't been able to find anything. So looks like we're gonna have to repair that one. All right, Ty, so give us a little overview of what you've done here to my excavator stick.
Well, you managed to put it back kind of in its place, so I had to cut out the overlap with a slit cut and then hammer this side flat in the same plane, so that when I plate it, it'll be, within about a 3/16 of an inch, which is
so
the same tolerance of the stick itself anyway.
So when you lay a plate on there, it's going to fit flush.
Yeah, we'll fish plate this over, and but I managed to do all the root passes, joining passes, in other words, of the actual stick. So it's actually functional now. And you can kind of walk over here and look at this side. You can see that weld right there. And those are usually, that's just one pass. And you had a nasty rupture where the middle of it was sunk in and puckered in, which is very strange.
Kind of impinged on itself and deformed it all downwards.
Well, it actually reverberated. The metal sprung open and then reverberated back, and it collapsed on itself, and that's why it puckered.
Yeah.
Very strange. A lot of force.
When I was working that machine, and I was just grabbing scoops of sand, and I'd curl it in towards the house of the machine, and it just kept coming and coming and coming. When I operated the joysticks to stop, it just kept coming, and I'm like, what the heck is going on?
Yeah.
I get off the machine, I'm thinking the ram up on top blew a seal or something that was allowing it to travel too far.
Right.
And then I realized they had all this cracking going on here.
All that was holding it was this thin little bit of webbing right here, which I went ahead and welded the crack shut. It's full penetration welding. So there's none of this V-grooving necessary, which speeds up the whole process. It's a cut and weld all in the same pass.
Yeah.
So it gives total joining, total penetration. And you can see this was actually performed in situ in place, so it was a very hot weld, and it tends to want to cut more than it wants to weld sometimes.
Yeah.
So that this is rejoined, and we can plate that. I'm just going back over the weld perpendicular like this to cover. The weld was done like that to begin with, and it's actually watertight. I had a big puddle of water on that this morning.
Yeah.
So, but it's 100% penetration. It's going to hold.
Have you been doing all this with your welder you invented?
Weld. Yep, that's an ugly prototype. That's probably number 4 or 5 maybe on the prototype list. So it's but it's functional. That's the one
And what rod are you using?
This is actually a 3/16 electrode Excalibur. So yeah, and it's 110/18. Has manganese in it.
110/18.
Yeah, and manganese is really hazardous. You don't want to breathe that crap.
Yeah, I saw you had a pretty good little plume of smoke going on your welding as I pulled in.
Yeah, I've kind of covered it, but I put a fan up here usually. But now that I've got the building under positive pressure, it just kind of lofts it out of my way. Hopefully, hold your breath basically when you're welding. I need to get a mask that actually has positive pressure in the mask with a filter.
Yeah.
Because I oftentimes end up holding my breath.
Yeah, so do I. It's not good to breathe that metal.
I like to leave my flux on, but we can just kind of uncover some of it just so you can see a little bit of the weld. See?
That looks good.
Yeah, it just tied right into this. And this may very well be solid. Even the slag that comes off is welded to the stick. It's hard to get off sometimes. I just leave it on there because it's just a wear surface. But now I'm laying the weld down nice and flat, going perpendicular to the direction of the root pass, and what that will do is give what we call maximum admixture, homogeneous welding, so that they're is much stronger result. So anyway,
You want to show off your welder to us?
yeah, it has basically 2 ranges that are usable on the I usually just run on the high range, and it's basically just a 1/3 the power, 1/3 the weight, 1/3 the mass in terms of size. But it has 3 times the performance and power, and this would basically last a welder pretty much all day on a project.
It's powered by batteries, right?
Yeah, it's got batteries in there, and I'm waiting for the latest Tesla batteries to come out.
Yeah.
Lithium ion, because right now I've got the highest quality AGM batteries I can get that are actually working very well.
Well, hold on to your hat because he's about to announce a whole new battery
Really?
technology.
Yeah, and Caterpillar had one too coming out called Firefly,
Well,
which is like a sponge, nanotechnology sponge,
yeah.
which would give us a lot more battery power density without so much size and mass.
Can you open that up?
This
or?
has a proprietary, it's actually got 2 patents on it. It's got a proprietary harness in there that enables me, it's basically cabled together much like a streetcar is from San Francisco that runs batteries or submarines.
Yeah.
But I had to manufacture my own cabling and clamps that are strong enough to hold it together because there's magnetic forces that want to unfurl the actual bolts on the clamps. So it's all double nutted and tightened down, and but it really
You
doesn't
want to show what's inside, or is that top
it's patented.
secret?
I mean, you can look it up on the I've got a patent in a frame. You really can't see much. It's
Okay.
kind of ugly in there.
All right.
But what's interesting is this, it did get hot enough to actually make this enclosure a little bit more flexible. I put a little weight on here just to flatten it out.
Yeah.
But the cables are getting a little bit warm after each pass. But it's just right at the right balance of, component.
What batteries you running in there right now? You got 8Ds or?
Just what I got down at, I used to run 3 8Ds, but they can't make 8Ds to save their lives. They're just junk. Never could find a good quality 8D.
Yeah.
So I went back to Group 31.
Oh, you're running Group 31s.
Yeah, and they're AGMs. They're not cheap, but they're good quality.
Uh-huh.
And it's got a, I don't know what do you call this, like an electrical vehicle
Yeah.
plug-in charger, basically. So I can plug this directly in here, and it will. Now it's charging.
Yeah.
Well, right out of turn it on. There goes my Tesla probe. Sorry about that. That's my robocall deterrent.
Yeah, there you go.
So yeah, it's charging on this. Only 15 amps of charge. And that's all it takes.
Uh-huh.
But I can actually take this out in the field, and if I charge it while I'm not using it, I can use this welder all day. Mind you, it's not a production welder.
Well, it's cool though because you can just recharge it off a solar panel if you had to out in the middle of nowhere.
Pretty much what's happening
Yeah.
right now. I got solar coming in,
Yeah.
506 volts coming in.
Yep.
Got black
So if
conduit.
you're out in some remote area on the tundra or something,
Yeah.
that'd be a great way to go.
Yeah, so it's actually being charged by solar panels as we speak.
Yeah.
And the 24 volts is generally what you weld with, like this Lincoln AC 225. That's 25 volts.
Uh-huh.
Okay, and that only gives me about 225 amps,
Right.
if you're lucky.
Yeah.
But the duty cycle is only like 10%, maybe 15 at best.
Uh-huh.
With this, I get upwards of about 90% duty cycle when I'm welding.
Wow.
But I can burn one complete electrode and then pause,
Yeah.
and then do my fabrication, do my layout, do all of my marking and inspecting, whatever, wire brushing, chip
Yeah.
hammering, whatever I want to do.
Right.
Line up metal, and by the time I'm ready to do the next weld, it's had ample time mainly to cool down the cabling.
Cool. The
That's really
cables.
the problem. The batteries haven't swollen.
Yeah.
And this is still kind of experimental because the battery technology just isn't there yet.
It
Really
is.
support the
It
idea.
is.
It's just expensive.
Yeah, it's
In
expensive.
fact, some of my land I'm looking at possibly turning into maybe a lithium mining operation would be nice. Because lithium's going to be the new gold.
Lithium,
Sure.
yeah, it's nickel that's really the major primary component in these new batteries. They call them lithium ion or whatever, but nickel is more prevalent than the lithium.
One of the things about this stick you may want to look at is putting a drain hole down at the bottom, because I notice there's a lot.
It drains through the pin.
Does it really?
Yeah.
Want to make sure there's not any rust in here or anything like that, but there's
Yeah.
probably been so much grease and
No,
hydraulic that
that
it's probably
boom
big.
actually before it broke was full of water.
Really.
Yep. So it had been cracked for a while because in the rain it had filled up with water, and as I was working, I noticed water was just running out of the bucket pin. And, you know, at first I thought I had a hydraulic leak because it was rusty looking water and just looked like hydraulic oil, but it was definitely just rusty water.
Or anything that has moisture on the inside, what it wants to do is erupt coming through the weld because it's very, very hot.
Mm-hmm.
It creates a steam pocket that comes right through, and it creates little volcano vents, basically, vents out.
Yeah.
And so what that wants to do is cause impurities in your weld. So you have to be very cautious not to let that happen. In this case, I just lean the stick upwards and lower my weldment area so the heat of the steam wants to go up there.
Have you had to move it much yet? Have you welded the other
I've
side?
already flipped it over,
You have?
gone all the way around. And
Your Thomas is handling it okay?
Tractor and welded that
Uh-huh.
flat, and then I flipped it over. It's hard to see underneath there. There's a big old gnarly weld on the back side that looks kind of like this. This one's a little bit smoother.
Yeah.
I've learned that I have to come in real tight on this electrode, which is very strange. Basically like you're cutting.
Uh-huh.
And that keeps the arc going a lot smoother.
Yeah.
Before I was doing a spray transfer a little bit more, where the arc was out quite a bit more.
Mm-hmm.
I mean, very, very tiny amount. You have to have a very good feel for this.
Steady hand, yeah.
You know,
It's like surgery almost.
yeah, I mean, you have to really have a lot of experience with this type of electrode because it just doesn't want to keep going at all.
Uh-huh.
And a lot of people get very frustrated. That's why it's not very popular at all. But I treat it more like a cutting operation. And it seems to, I'm actually plunging it into the subsurface of the weld. It's a puddle.
Yeah.
And then it just literally keeps going. It likes that. So the other thing too is, if I were to weld this whole thing on one pass, there'd be so much heat energy in this thing that it would cause the metal to expand so much
Uh-huh.
that once it cooled down, it would tend to try to crack the other sides or possibly even other parts of the weld.
Right.
So what I try to do is do pulse welding, where I do maybe a third of electrode at a time.
Mm-hmm.
And what that does, it allows the heating effect to create enough heat to get rid of the impurities of the weld puddle, get good admixture, but at the same time not overheat the weldment, so I don't get
Distortion.
deflection and distortion
Yeah.
and creep,
Sure.
because that causes more problems than you want to chase. This is a
Well, how close do you think you're getting to putting this thing back on the machine?
well, I mean, once I do this weld here and just finish this up here today, you can stick it back on the machine now.
Well, I know, but we're going to gusset
But
that,
I mean,
right?
if you wanted to gusset it and fish
Yeah.
plate it, then,
I think we should.
you know, I'm pretty confident that would hold up fine. Actually, you could actually
I know, but it's off.
grind it down real nice,
Mhm.
throw shellac some Bondo on there and repaint it. You wouldn't even know what happened.
Yeah.
But once we plate it, you know, we'll probably plate it in such a way that it looks.
Well, this is an opportunity to make it stronger than it was, you know. Let's plate it.
Wouldn't take much to do that. So, you know, I think all you really need to do is just overlap this. You could just do that by, you know, making another.
Well, I want to fill it in here.
Yeah, well.
Make it look. It'll look a lot more factory if you come off of here like that, and then
Yeah,
just
you
fill
could.
in the whole thing.
A
Yeah.
lot of welding.
Yep. It sure would be nice, and then we can just paint it red, and like
What
you
I gotta
said,
be
you'd never
careful of,
know.
though, see, as you can see here, my welder will actually cut right through this.
Mm-hmm.
So probably what I want to do is run the plate down here on this weld,
Okay.
where I've got.
So leave yourself a little
and
gap?
this. Yeah.
Yeah.
Well, I want to get it right in here, to where I can come in here and just fill that in. It'll match up,
Right.
because my weld will actually fill that in.
Yep.
To where it would be flat.
Oh, that's fine.
That's what I want to do.
That makes sense.
Because otherwise, I'm running the risk of
Well,
blowing through this.
that way too gives you room to get in there and
Yeah.
fill that in and really make it look pretty.
It doesn't really need to be any higher than this, but
No, it can't
wanna
be.
keep it as low as-
can't be because it'll start to
Right there.
interfere. It'll start to interfere with the yoke that this fits into.
so this is your plane right there.
Yep. Exactly.
So your machine will swipe through here
Mm-hmm.
and wipe this area. So I got it pretty good and flat here, see?
Yep.
Your side's actually flatter.
Yeah.
But this area from here to here was puckered so badly. And the more I hit it, I use my small hammer, well, my pipeliner hammer,
Uh-huh.
and I beat this pretty good, but it was all heated up. I mean, I had this whole area was heated this way and then diagonal.
Yep.
Heated up real good. This one was actually lower, so what I did was I overheated this and I put water on it, and that actually caused it to rise up a little bit. So I was actually able to cause
Yeah.
that to come back up.
That material's what, like
Push
3/8 thick?
Not even that thick.
Yeah, that's amazing, huh?
1/4 inch. Just a little bit over 1/4.
Yeah. I was surprised how thin it was.
Yeah.
I mean, it gets its strength from its design more than it does from the material thickness.
Well, I think your main
engineering
strength is the webbing and the cap.
Yep.
And then these.
Well, and you see this boss here too. I'm sure that's some pretty substantial.
This webbing.
Yeah.
See that? But at least you got lucky. It's equal. Symmetrical.
Well, you know, notice it
cracked
cracked across the top here at the end of the webbing.
Oh yeah.
So that's what the webbing's what held it.
I thought about trying to put a hydraulic press on this, heating it up, and smashing it back in. But then I thought, no, the time invested
Oh my
in that,
God, that would be a
I'm
nightmare.
wasting time. It'd
not
take me a
that
good,
important.
probably 6 hours to do that.
Yeah.
And I don't really want to do that. I'd rather put the time into welding and
Exactly. I mean,
engineering the gussets.
the new, I found a used arm through Fresno Tractor. And it was $3,700, but plus freight to get it out here from back east.
Oh, back east.
Yeah. So I mean, you can only go do so much where it gets to be, you know, counterproductive. You're almost better off just buy another one. But I figured, you know, if we fix it, it's gonna be stronger than anything I can buy.
Oh yeah.
So might as well go this route. It'll be less money too.
The other side's a little bit more gnarly, but this side's, you know, not as bad. Although it just had a little different type of injury. So,
all right, well,
make it stronger than before. That's the key.
So here's the final result of the weld repair my brother did with his stealth welder. Works on batteries.
Yes.
And it'll weld plate as thick as you want to go. There's some of this is 3/4 thick on top.
Yep. Intrinsic.
All welded with the stealth welder. It can be recharged with a solar panel.
Yep.
Pretty cool.
Soon to be powered by Tesla lithium-ion batteries, hopefully. So.
Yeah.
But it gives the metal what it wants intrinsically, so it actually self-moderates energy and enables me to do very deep penetrating cut welds. Basically, I call them a super stick weld, which is like a cut and a weld all in one.
So we're about out of battery right now, but I just want to just show you this and have Tyson explain the technology behind his welder. And we've ended up plating the sides where it was ripped. It's been armored.
Armor plated. Yep.
Armor plated. What was the thickness on the
High
plating?
tensile strength steel, 3/8 on the sides and 3/4 on the top. It's got a apron on the top and it's encapsulated, so it's gonna be actually stronger than it was. So it's actually a lot stronger than it was to begin with.
Yeah, I'm looking forward to being able to really wrench on it now with a ripper and not worry about it. So we'll take some more film when we put it back on the machine, kind of show you our technique to handle this piece of machinery here. It's probably, I don't know, 5,000 or 6,000 pounds anyway.